Okay, it is the 30th of June 2023, and this video I want to show you what you can do with the distributed testing stuff that I've built for Codex. So we'll do some brief introduction and then something hands-on. I show you this picture. Testing in Codex, what runs, when, where, and why. Not all of it's filled in. We have a whole bunch of unit tests and integration tests that are in the repository of Codex itself that I won't be talking about in this video. Then there are distributed tests and continuous tests. For now, you will find them in the CS Codex dist test repository. That's this thing over here. If you clone it, the moment it will look something like this. Bunch of branches, bunch of garbage that I'm working on. Very good. So the distributed tests, the middle row here, it's not actually running automatically or in any place in particular, but you can run them manually from your local machine, or you can run them in a cluster, and that's what I want to show you in this video. Yes, and how to change them and how to see the results we'll also cover. So in the big picture, such as it is, the distributed testing runs in a Kubernetes cluster. That is the big box around this. And then the top two smaller ones represent namespaces for the distributed testing. So there's a distributed tested runner namespace, and there's a namespace for the Codex instances themselves. And these blocks are all red. That means they are transient or non-persistent. Basically, the test will create a bunch of Codex nodes and whatever else it needs. It will run a test, and then it will destroy the nodes that it created. So these are alive only for the duration of the test. The test runner itself is also non-persistent, and you can run it in one of two ways. Like, you can run this test runner from inside a Kubernetes cluster like it shows in the picture, but you can also run it from your development machine and then point it at a Kubernetes cluster elsewhere, and it will create the namespace and do its things. And that's what I will be showing you if all goes according to plan. So to run this on your local machine, you need one of these, like a Docker, Docker installed on your local machine, and you need this thing, Kubernetes in Docker. You can turn it on right here, enable Kubernetes, then you apply it, and it takes a moment to install, but then you have it. Also consider getting yourself this thing, OpenLens. It's specifically for Kubernetes. You point it at one or multiple clusters, and it easily lets you see what are the namespaces that are online, what are the pods, what's being deployed, is anything crashing or not. It's quite handy. So then, once you have cloned this thing, this repository, I was just working on something with continuous tests, but I'll just stay on this branch, open it in my IDE, and then you can see there are a bunch of tests right here. Let's look at some example tests. The metrics, the marketplace, and the Codex logs. You can find them in the assembly here. Maybe I also show it in the terminal. Nah, maybe not. This is just following the file structure. Basic tests, example tests, and then this contains 3 tests: the Codex log example, the metrics example, and the marketplace example. So you can run these individually from the IDE pretty easily. Visual Studio Code can also do this with a little plugin, and you can of course run individual tests from the command line, with the command that goes like this: .NET test tests, and then tests is the name of the project, this one right here, tests. This will run all of the tests in the project, but if you want to run just a single one, you can do filter, and then you just give it a name, for example, Codex log example. Then it will try and match this to the test names, and it matches only one, so then it runs just that one. I can do that from here, and what we'll see happening in the Docker desktop is containers will show up. Some of these are Kubernetes internal containers. They're not our own code, but some of them are. And you can use the open lens to see now it created a namespace. It's already terminating because at the end of the test it cleans it up. And the Kubernetes resources will be created in the namespace. At the end of the test, the namespace will be deleted, so all the resources that were created will be deleted when the namespace that contains them is deleted. So deleting always takes longer than starting, so it takes a moment for this thing to stop, and then at the end it turns green. Hooray! So this just says test passed, but that doesn't tell you a whole lot. So it'll be interesting to see what more output that we have. So we go to the place where the tests were started from. That should be in here. And there should be a logs folder. These are organized by date and time. So today is the 06/30. And you can see there is an example tests log because I ran something from the example tests file, which will tell us global setup was performed, which version of which images were being used, and then we ran the Codex log example test, which took 4 seconds to run. The cleanup, as I said, takes a lot longer. It took 40 seconds to clean up the resources, because that just takes a lot longer in Kubernetes. But the test itself took 4 seconds and passed. Okay, very nice, but I want some more details, so it makes a folder. And in the folder you can see exactly what happened. Oh, I see I left debug output enabled, so it has all these debug elements as well. Normally you don't see those, but you can turn them on if you want to. So you can see that a Codex node was started at a given location. It gets a name, container 0, that took 3 seconds. And then an upload was performed. Like we generated a test file here of 5 megabytes, we uploaded it, we got a CID, and then we downloaded the container logs. And as you look at the code, that's exactly what happens here. So we generate a file of 5 megabytes, we upload it, then we download the container logs, and then we assert that it contains the text uploaded file. So well, obviously that passed, but we can check it manually because the container log is also saved for us here. So this should contain, what was it, uploaded file? Oh yeah, there it is. And you can see like the CID is QNUF1S, something like that, QNUF1S there. So this is a basic example of how you can run the distributed tests. They have a bunch of configuration to them that is useful to be aware of. It is in the distributed test core configuration, where basically I usually just change it by editing the code in here. If you run it from inside a Docker container, you can influence these things with environment variables. So you can control things like where are the logs saved, do I have debug enabled? Well, I set this to true, so now I have the debug output. the default log level of the Codex nodes set to trace. But the reason I'm showing you this is, most importantly, there's a kubeconfig file which is currently set to null. When you set the kubeconfig file to null, that tells the framework that you want to use your system default Kubernetes cluster. In this case, the Docker desktop one, because this one is addressable without a kubeconfig file. So I set this to null and then I use that one. The important thing that to match is the runner location, which is then set to external to cluster, meaning my test runner is on my host machine, and so the way that it has to address containers in the cluster is different from if it were located internal to the cluster. If it's internal to the cluster, it has to use the internal addresses, and if I'm external, I have to use external ones. So the test runner needs to know where it is running. So you can set that here, and because I'm not using a kubeconfig file, I'm external to the cluster, it is set to this. But if I were to run this against a cluster in the cloud somewhere, I need to plug my kubeconfig file in here. So it's just the path to kubeconfig.yaml. This is still external because we're still running it from the local machine against a cluster that is specified by this YAML file. But if I want to run it inside the cluster, I would have to change that as well. So I suppose you will want to see that. And we can definitely do that. But I did set up for myself a bunch of helper scripts, and I have a kubeconfig file, which you might not have. And if you don't have it and you need it, then you should ask Slava, because he is managing the cluster, and it would be good if he knows, who is using it. If you have the kubeconfig file, you can plug it into OpenLens, and then you can view the status of that cluster the same way that you can view the local one. Just it becomes a different tab, so that's nice. And it has pods running. So the first thing we need to do is we need a little virtual machine in this cluster that we can connect into, from which we will run the tests. So I have a script that will start something. It will start something called the Ben pod. Here it is, Ben pod. It's just a small Ubuntu container, and by itself it can't really do much. So I made a little setup script that just installs and clones a bunch of stuff, so I don't have to do that every time. And here's a copy script to copy that into that container. It also copies the kubeconfig, which we need, and there's a connect script to dial into it. So here I am. You can see there is the setup. I have to give it execution permissions. It's gonna install Vim. It's gonna clone the repository, do a bunch of other stuff, and the kubeconfig file is in opt. So there it is, kubeconfig. So now I have the same code base that I have in my IDE, but I have it down here in the cluster. And before we can run it, we need to mess with the configuration a little. Like I said, we did actually bake this thing into a Docker image, I think, and then it sets it with environment variables, so that makes running it automatically easier. But if you want to just sort of hands-on play with it, you're gonna have to do this. So what I need to do in here is put the path of my kubeconfig, YAML, and I have to tell the runner that we are now internal to the cluster. that should do it. Go up one. .NET build this. Alright, very nice. And then we'll use that run command to run the same test. So we do .NET test tests, that's the name of the project. And then we filter for Codex log example. So if we go to our open lens and we look at the namespaces, this test runner should be creating a namespace in the cluster with a random GUID. Here it is. See, it makes a Codex test and then some random blub where it creates its resources. And then after a few seconds it terminates it. It cleans up after itself. Again, the cleanup takes longer than the actual test. "40 seconds it took last time. I would hope this cluster is slightly faster, but you know, there's no way to know. There we go. Test passed. Now, I'm pretty sure it wrote logging for us here too. Probably in a similar sort of location. Codex test logs. Yeah, and so again it's pathed by date. There is a high level log, which is the name of the test fixture, example, telling you, which versions were used, which tests were run. And then there is a more detailed one for the test itself. Alright. This is where I'm going to leave the recording. This covers the basics of the top part of this diagram. I hope you'll give it a try. Run these tests yourselves and run into trouble. I want to say most of these tests are in a state where they run and pass with a fair bit of reliability. Sometimes they don't, and that can be various reasons. There are a whole bunch of timing sensitivities and all that, so keep a good eye on those log files. And I suppose in the next video I will tell you about the continuous testing adventures, which uses the same infrastructure, use the same code base, we reuse the same code for most of it, but has a different approach in general. So thanks very much for your time and attention, and I hope this was useful. And I can't believe you actually stuck around for this whole thing. So we'll see you around.